everyone, this is a Houdini tsunami tutorial. Without further ado, let's get started. I have imported the camera and the buildings. Let's see the settings of the project. 30 FPS, 150 frames in total. Then we need to check if the resolution is right. Set it to 1280 by 720 as needed. I want to render it from the first frame, so we need to offset 100 frames forward for pre-simulation. Since the simulation of the first 100 frames is not steady, which is not what we want. Here I put a model. We can see the proportion of the buildings to the man is proper. Well, let's create a tsunami mesh. Drop down a geometry. Name it Ocean Surface. Drop down a grid. It'll be the scope of the tsunami. I just applied the values I tested it before. Increase the rows in the columns, but not necessarily too high. Compared with the buildings, the current subdivision is fine. We set a rough shape first. The tsunami flows in from the right, so we need to raise the grid to form a slope. Apply rail point B box to get the range of the x-axis, which is within 0 to 1. We add a ramp to control it. Assign the result to a variable. Then we add height on the y-axis to it. When we adjust the ramp, the grid changes accordingly. Lastly, we multiply the result by a value to control the height of the tsunami. Now we adjust the slope with the ramp. For a smoother transition, we change it to B-spline. OK. Come into the camera view. I want to let the tsunami flow into the city from the distance. Let's animate it. Tilt it a bit first. Place it in the back of this building in the beginning. Then let it gradually move toward the camera. Here we can apply -$F directly. According to some references, the speed of tsunamis on land is about 30 meters per second. The project is at 30 FPS, so it moves forward with that speed, which is close to real situations. It is necessary to take it into consideration when we work on the project. Otherwise, unreasonable speed may lead to unrealistic dynamic. Well, we only animated the translate on the x-axis, so it just moves along the x-axis. But we rotated the tsunami mesh just now, which made it move obliquely. So let's animate the translate on the z-axis. Multiply $F by 0.7. OK, fixed. Well, that's a rough tsunami animation. Next, we create ocean waves. Click the shelf tool directly. The materials and the notes about ocean waves are on hand. Pretty convenient. Copy these notes. Paste them here. Wire grid 1 to Ocean Preview. delete this node. This is for rendering the volume of the ocean. Add a 1 to the end. Now the materials are applied to the grid. Next, let's adjust the ocean waves. Into the camera view. Well, the subdivision is a bit low, which is not easy to observe details, so we can raise it a bit more. The grid is pretty large. If we do it entirely, preview will be very slow. To avoid this issue, we just need to raise the subdivisions within the scope of the camera view. Enlarge the camera icon a bit. Here it is. At the first few frames, the camera view reaches as far as here roughly. Here, create a box. Set its size and position as needed. Then create a group. Name it for a convenient use later. Now we can only subdivide the polygons in this group. But for that, we need to modify the type of the group, since subdivide only works on primitives. Let's convert the points to the primitives. Select the group. Note here, with the default subdivide mode, the grid will be divided and cannot connect well when it is displaced later. We change the algorithm mode here. Alright. Let's see the moving direction of the waves. It is the opposite now. It should flow toward the negative x-axis, so we set the direction to 180. Meanwhile, I'd like to make the flow forward uniformly to strengthen the momentum of the tsunami. We increase the directional bias. This parameter also affects the dynamic of the waves. If the value is pretty small, the waves will just move up and down in place. Bring it up a bit. Now the waves are moving forward. Next, let's fix the issue of wave repetition. But before that, let's raise the subdivisions a bit, which is good for revealing details. We can see there are some repeated waves. Increase the grid size. Meanwhile, the ocean waves are a bit weak. We increase the scale. Well, the part of the tsunami mesh near the ground doesn't need to be displaced. It penetrates the ground now, so we need to flatten it. We can multiply the height of that part by this variable. Select B-spline. OK, fixed. Then we continue to adjust the waves. You see, the tsunami moves with pretty slow animation. We can animate the time offset. It's good now. Regarding the ocean spectrum, I'm going to apply a large one and a small one. The large one is mainly to control the large waves. The small one is for building a proper scale and adding some details to the ocean. Duplicate the node. Just keep the time offset animation for the large one and remove it for the small one. This way, the tsunami waves look more natural. Then we'll adjust the large spectrum, tweak the seed to get an intended shape. To accentuate the dynamic of waves, we increase the speed a bit and the scale. Bring up the grid size as well. The tsunami is not high enough. To bring a better visual shock, I want to make it block half of the sky in the end to intensify the sense of disaster. Okay, tweak the ramp in detail. This parameter controls the height of the tsunami. We raise it a bit. Meanwhile, I'd like to animate it to make it rise gradually. In the beginning, it shouldn't be too high. If this building is flooded entirely, then there's no center of interest here. So we set a keyframe at about the 10th frame. Then raise the height of the tsunami when it's about to get to the camera. The change of height makes it more majestic. Then, let's adjust the ocean spectrum further. Currently, the waves are still not high enough and not noticeable. Take it up a bit. It's a bit smooth on the surface. We can offset the grid center slightly to get an intended surface. It's better now. It was a bit flat before, but now with more details. Meanwhile, there is a large wave to flood this building. Pretty interesting. Then we merge the small spectrum, slide the seed. The speed is not necessarily high. Display it alone to take a look. No need to keep the mask, remove it. Same to the large spectrum, uncheck it. We can change the small spectrum a bit to differ from the large one. This way it'll look more natural. Small waves can be tweaked based on the scale of the buildings. This way we can easily get a proper scale on the surface. To avoid the wave peaks being too sharp, we bring down the chop a bit. Alright, done with the ocean waves. Check point velocity and cusp attribute. We'll use them later. Okay, let's go ahead. We can see the outline is a bit even and lacks some height variations. So let's add some obvious changes to bring some high contrast, thus avoid being too boring. We apply attribute VOP, place it here. I'm going to use this method to display the top of the tsunami. Still, we need to get a range on the x-axis first. Separate x, y, and z axes. Drop down a turbulent noise. Select 3D noise. Add the noise to the original position. Select original party noise since it runs fast. Increase the amplitude, reduce the frequency, or it'll look fragmented. Here we just need large waves. Details are not necessary, so we turn off the roughness. Disable ocean evaluation for a better view, and we only need the noise on the y-axis. This way the noise only works on the y-axis. Besides, we only let the noise affect the top of the tsunami, So multiply the noise by the top range of tsunami. Add a ramp. And tweak it. Come into the camera view. Similarly, select B-spline. Alright. Then let's tweak the noise in detail. Promote those parameters. Increase the amplitude a bit. Animate this offset as well. If it is still, it may look a bit stiff. No need to make it too fast, a lower speed is fine. Enable the ocean spectrum to take a look. We can see the tsunami outline has some height changes. Pretty natural now. Actually, when we simulate natural elements, the more random they are, the more natural and realistic they will be. Besides, I want to lower the height of the distant part, since the tsunami is basically of the same height. A height drop can bring the scene a better sense of space and distance. Just now we added height variation on the x-axis. Now we apply the same method on the z-axis. Copy the code, change x to z, remove it, multiply at p.y by the range of the z-axis directly. OK, now we can see the height change appears. Tweak the ramp. Come into the camera view. Select the B-spline as well. To keep the height of the front part, we can add a handle to adjust the distant part only. Perfect. With a height drop, it looks better. Alright, done with the tsunami animation. Next, let's delete the bottom part. Move down the whole tsunami first. And then add a blast to delete the bottom according to the height. There are some isolated points left, like here. We need to clean them up. Otherwise, some problems may occur when rendering. To make it run faster, we add a compiled block to pack these nodes. It's faster now. Then we cache it out. Set the cache path here. Alright, let's cache it. Oh wait, I realized the downsample was set to 2, which reduced the details of the model. Take a closer look. When it's 2, the details are a lot less. Okay, set it to 0. Good now. Let's cache it. Alright, here it is. Obviously, it's pretty gale force. Perfect. At the end of the animation, I left some room here to create splashes later. Till now, the animation has been finished well. If you're not satisfied with yours, I suggest spending more time to refine it, because we will extract the wave peaks to emit particles as splashes. So the splashes caused by tsunami hitting the buildings and the point in time when the building collapsed are all based on the animation of the tsunami. If the animation is not good, we may have to rework on the previous process. Therefore, create a good tsunami animation before your next step. This way, we can minimize rework. Next, let's set up the rendering and set the material to see a general effect. That's really important. We'd better get it done early. In the final rendering, the ocean spectrum will be in the material, so they're not necessary in sub. Let's make another tsunami without ocean spectrums. We'll simply duplicate the compile block and skip this ocean spectrum. Okay, apply an invoke compile block to read the nodes in the compile block. Name the first node, copy it, and paste it here. Drag and drop the last node here. Connect grid 1 to invoke 1. Set display flag on invoke 1. We can see the new tsunami is basically the same as the previous one, except for lacking ocean spectrums. This is exactly what we want. Generally, the ocean spectrum should be added on a flat primitive, and the texture will be normal. If it's added on quadratic primitives, the texture will look stretching, which is abnormal. So before adding ocean spectrums, we need to get the rest position of the grid. This is the rest position. We input rest to material. Then drop down a cache file. Rename it. Click Save to Disk. Okay, done with the cache. It's with the rest attribute now. Drop down a null node. Then we import it to a new geometry node. Rename it. Paste the path here. These two are for rendering. One is ocean surface, the other one is ocean volume. Also, we need a new tsunami here. Remove this node as is useless here. Alright, assign material. This is ocean surface. This is ocean volume. Then let's adjust the material. Turn off diffuse intensity here. Water doesn't have diffuse property. Reduce reflect intensity a bit. Increase reflect roughness a little bit. Come to refractions. I want the water a bit transparent. Set it to 1 for now. Okay, foam here. If waves are too high, there may appear white caps on the peaks of the waves. I don't want that. Because we will simulate white water separately later, so set white cap intensity to 0. Let's move on to ocean volume. We adjust the color slightly to make the water look a bit turbid. Here I just apply my tested values. We don't need the scattering phase. Turn it off. A little shadow will be good. Or the color inside the ocean will be a bit too dark, which will look bad. Anyway, we will test more later. Next, we need to add an environment map. Rename it. I've prepared an environment map beforehand. Take a look. It's like this. I want the sun behind the tsunami to get a backlight effect. Considering this is a disaster shot, as the tsunami is overwhelming the sun gradually, it feels like a real disaster. Check clip to positive y hemisphere, or else the bottom half will uplight the scene. And the tsunami will also be affected by that, which doesn't conform to physical phenomenon, so check it. Then we create a main light. Name it sun. Its direction should keep consistent with the sun in the environment map. Anywhere will do, because the position doesn't affect the lighting. The point is their directions must be consistent. So we can move it to a position where we can adjust the direction conveniently. Also, I apply tested values. Roughly this direction, like we said, backlight. We select the sun for the type. This way the light won't be affected by its position. Okay, done with the lighting. Next, rendering. Select camera. Then set the render path. Remove unwanted channels. Use PBR engine for rendering water, since it runs faster. Reduce max rate samples for now, because we need a faster render speed in the testing phase. There's no diffuse required, so we remove diffuse quality as well as SSS to improve the render speed. Here is max number of indirect samples. When it is reduced, the render speed will be improved. Tile size can be set according to your hardware. My best option is 32. Then we set candidate objects. One is ocean, the other one is volume. Candidate lights are two suns. Just keep it by default. Let's render it. Oops, I forgot to add ocean spectrums and import the rest attribute. Cache ocean spectrum out. Set the path per your reference. In this material, we need to replace this original position with the rest position. Import rest. Select vector. Connect it to sample positions. This way the wave can match the previous effect. Also, we need to add rest for ocean volume. Let's render again. This is the current ocean effect. There seem to be many dark areas. The density of ocean volume can be lowered a bit to make it look a bit more translucent. Otherwise, the dead black color looks bad. Reduce shadow density as well. We can see here the ocean volume is exposed now. We can fix it in Mantra. Cut it and paste it to Forced Phantom. Actually, the render speed now is very fast, just 25 seconds. We can increase pixel samples a bit. Render again. Now the light transmission is a lot better than before, but it seems a bit too much. We're making a tsunami after all. Due to the large amount of water, the transmission is not supposed to be this high. We reduce the intensity of light to lower the light transmission. I reduced the intensity of the sun because it affects the light transmission more. The environment light is mainly to affect the lightness of surface reflection. We can adjust it as needed. I'd like to brighten the surface reflection, so raise the light intensity of environment light. To avoid light transmission being too high, we reduced the intensity of the sun. One's been raised, the other's been reduced. When making adjustments, we need to consider their different roles. Currently, there is no channel. Let's set it in order to check the effect in detail. Let's add channels in Mantra. Here, use export variable for each light. Oh, there's still another issue. The bottom of the ocean is not flat. It was flat when we deleted the lower part with add p.y. But after the ocean spectrums being added, it is displaced, thus above the ground in some places. So we need to handle it. Drop down a grid. enlarge it. We can see it intersects the tsunami now. Render it again to see the effect. Well, I forgot to set matte, yet we can find the reflection and transmission look better now. Environment light makes the reflection brighter. Meanwhile, the transmission has been reduced a lot. It's pretty close to the desired effect. Let's see these channels. There are two lights in this scene. The channels of these two are separated. We can see everything looks good now. Okay, let's add a mask for the lower part. To forced matte here, we add a render ocean mask. Render again. Well, the part that is lower than the grid is trimmed, but some areas are above grid. We come into render ocean and move the points that are lower than ground down somewhat. Drop down an attribute wrinkle. If ap.y is less than 0, then ap.y equals to a fixed value. This way, all the points that are lower than ground have been moved down a distance. Hide these two. Now fixed. Add the attribute wrinkle to ocean volume as well. Render it again. Actually, the render speed is fast, but the quality is a bit low. We can increase the quality to observe details more clearly. Increase sampling quality of environment light. It affects image quality quite a bit. If we just increase the sampling in Mantra, the noise on the render image cannot be fixed completely. So sometimes increasing sampling quality of environment light is essential. In the Mantra, we can also turn down volume quality to 0, since there's no volume in the render image. This way, the render time can be optimized a bit. Alright, let's render it again. Okay, it's done. The issue at the bottom has been resolved, and the quality is higher than before, with the noise reduced a lot. However, we will improve SimRes in final rendering, as we can still see some slight noise. But that's not a problem in terms of checking the effect for now. Well, I think we can refine details a bit more. Duplicate this ocean spectrum. It won't be put in this pipeline, since it's just for adding some details. We drop down a grid to visualize the adjustments. Since we are making subtle details, this value should be small. That being said, it shouldn't affect the waves. If it does, the whitewater will be intersected with the surface. Reduce the scale a bit too. Increase resolution exponent. Tweak the seed to find an intended effect. Alright, it's done. And then we render it to take a look. We need to cache it again. Render it. This is the effect with small details added. Compared with before, the reflections and highlights are more scattered, which adds more details to the ocean. It looks pretty good. Now we are ready for the next step. See you soon.